Moving on, the next two videos will be about compound probability, which is when you have multiple events. Some events are independent and others are dependent. First, we'll look at independent events. That means that the two events do not affect each other. You'll often see wording in the problem that says that you're drawing something with replacement. So for example, maybe there's a bag full of marbles, you take one out to see what color it is, you put it back in, and then you take out another marble. Because you put the marble back in the bag, it doesn't change the probabilities from one round to the next. Some examples of things that are independent: tossing a coin multiple times or rolling a die. The fact that you get a heads on the first flip of a coin does not change the probability that the second flip would be a heads. And in general, what you'll do here is you'll take the probability of the first event, the probability of the second event, and you will multiply those to find the probability of both of those things happening in succession. A dresser drawer contains one pair of socks with each of the following colors: blue, brown, red, white, and black. Each pair is folded together in a matching set. You reach into the sock drawer and choose a pair of socks without looking. You replace this pair and then choose another pair of socks. What is the probability that you will choose the red pair of socks both times? So what's important here, the way we know that it's an independent event, is because we're told that we replace the first pair of socks before we pull out the second pair. There are 5 pairs of socks: blue, brown, red, white, and black, and only one of them is red. So the probability that I pull out a pair of socks that is red is 1 out of 5. Since I'm putting that back into the drawer, now the second time I draw a pair of socks, the probability that that second pair is red is still 1/5. Recall that we multiply fractions straight across the top and straight across the bottom. 1 times 1 is 1, 5 times 5 is 25. So the probability of drawing one pair of socks, putting it back in, and drawing a second pair of socks, and both times getting the red pair, that's 1 out of 25. You'll often see some examples with decks of cards. You should know that a deck of cards has 52 cards in it, and that there are 4 suits: hearts, diamonds, clubs, and spades. Within each of those 4 suits, there's 13 cards each. The cards are 1 through 10, the 1 being the ace, and then there's a jack, a queen, and a king. The hearts and the diamonds are red, the clubs and the spades are black. So here, I want to find the probability that I draw one card and it's a king, then I put it back, and then I draw another card and it's also a king. So within a deck of cards, there are 52 cards total, and 4 of them are kings: the king of hearts, king of diamonds, king of spades, king of clubs. And since I'm putting that card back, when I draw the second card, there's still 4 kings in the deck out of 52 cards total. When I multiply and simplify, this gives me 1 out of 169. This little tilde in front of the queen means not. So this notation says find the probability that I draw 2 cards with replacement. The first one is not a queen, and the second one is a 7. So there's 4 queens in the deck, 1 for each suit. There's 52 cards in the deck total. So if I just want the ones that are not queens, I would do 52 minus 4, and there'd be 48 cards in the deck that are not queens, and there are 4 7s out of the 52 cards in the deck. When I multiply and simplify, this works out to 12 out of 169. And then this last example is asking me to find the probability that I draw one card and it's a spade, then I put it back in the deck, and then the next card I pick is either an 8 or a 9. So there's 4 suits out of the 52 cards. 52 divided by 4 is 13, so there's 13 spades. There's 4 8s and 4 9s, which means there's 8 cards that are either an 8 or a 9 in the deck. When I multiply and simplify, this works out to 1 out of 26.